about understanding blood types, the ABO and Rh
Right there,
groups.
you'll come after me.
There
like
are
it now.
so many
Oh, no!
misconceptions about
here?
blood typing. Oh my gosh, you can eat
Right there.
based on your blood
You
type.
must be
You can
and
check this out. You
hold
can
it. You're
find
having
your
over a
perfect
loaf.
match
Seriously?
based on your blood
You're
type.
having
It's
a
really pretty
lover
ridiculous,
place
but
here.
you know, a lot of people
Where
are
are you making
confused
stuff?
because
You're having a
historically
lover
people
place.
had to have blood
Some
tests
kind of
before
forever ones
marriage.
in the 1970s.
In truth, this
There's
really didn't have that much
1960s.
to do with blood types as
No,
much as it had to do
it
with
wasn't
disease,
me here.
especially
Looked like a
diseases like
choker.
syphilis. But it accounts
What
for a
the
lot of
hell
the
is
confusion
going
that
on?
goes
How
on
come
about
half
blood
the
groups,
lover
and there
place?
are
There's
many
nothing to
blood
know
groups.
here.
Certainly the
There's
most
Jeff,
important and the
yeah,
focus of this video,
however.
the ABO blood group and the Rh group. Interestingly enough, we share
Now go to
the
a right
ABO
place.
and
You're right
Rh
here.
blood
Now
groups
you're
with
just
our relatives,
you're
apes,
complicated.
chimpanzees,
You're
bonobos,
complicated.
and gorillas.
You must be have access.
Okay, so students are totally plagued
You're
by
not- you're
these
never
donor-recipient tables, and they
There's
think that they have to
78
memorize all
memorized here
this.
all
For heaven's
over.
sakes, don't
I
do
know.
that.
And isn't that great?
That's what the Penguin Prof
You're
is for.
having
Okay,
a
we're going to go
place
through
of
what all of this
lion.
stuff means
I
so that
think
it
you're
makes
lying.
sense to you,
Well,
and then you
if I
don't
had
have to
the lion.
memorize anything.
Well, then
One
you're
quick
fly
request,
heavens.
if you can, please
Nothing
donate and give
over.
the gift of life.
Maybe you must
One
be
blood
absent.
donation can
No,
save
I don't
several
think so.
people. Just a
There's
tiny bit of
nothing
history
to be
here. These
scary.
blood groups were discovered in
scary
around
like this is
1900 by
scary.
Carl
I
Landsteiner.
hear
He
a
wondered
now. Yeah,
why
just
some people
so.
were saved
I
as a
see
result of
little
blood
bird.
transfusion,
Here, the right
but
here,
some
right
patients
here,
died.
right there.
And
The
boy,
running
that's, I
tail
think, a
has
really
a
good
little
question. He
hey,
received
dirty.
the Nobel Prize
Yeah,
for this work in
you're having it.
1930.
No, you mustn't be here.
Blood
like
types
this.
are
They're
inherited
not there.
genetic traits,
You're
so they're just like
liking
all
your
the other things
colony.
that we
You must
inherit,
colony
which does
lover.
again make me think about this date by
Isn't
type
it
thing.
great?
What if I can come up with a match
me
by
here.
earlobe
I
type? I mean,
think
that
the world
makes
large.
about as much sense.
Really?
Anyway,
So
the thing
cool.
that's confusing is
No.
that blood typing, the ABO system,
honey,
is
it's
not
more knowledge.
inherited in Mendelian
Yeah,
fashion.
that's knowledge.
So
Yes,
it gets
I
a little
know.
bit
Isn't it
complicated because we
great?
have 3 alleles. And don't worry, we're going to go through that. I'm going to have an analogy here. Red blood cells look a little bit like donuts. Of course, they don't have the hole in the middle. They have a little depression. But my ABO analogy, we're going to look at donuts and sprinkles. Okay, and hopefully we'll make some sense of this.
I know, isn't it right? You're right, you're a spring. You're right there, isn't it right? No, then you're right there. Hold me right there before you. You're right here. Good luck. Good luck.
This is the Penguin Prof channel.
Is anything
so
okay
you're going to get a
here?
little bit more out of
Yes,
it.
no.
This is the idea. I'm showing you only the carbohydrate
Yes,
portion of
very
the antigen.
carefully
So
here.
there's
It
another
just
section that
broke
kind of anchors the thing
There's a
into the cell membrane.
presentation. We find
A plain
presentation
donut
like
has
this.
a sequence that looks like this. That's
There's
the
a
base
right
unit.
there.
For people
There's
with
not
A
right there.
sprinkles, A antigens,
You must be
at
a-
the end of the
I
base,
know,
you
isn't
add
it
one
great?
more unit.
must
It's
be
called
half over.
N-acetylgalactosamine.
We
and
don't
that's what it
allow
really
here
looks
all
like.
over place.
People with B sprinkles, the
I'm
B antigen,
sorry,
instead of
miss,
adding
but
that,
I
you add
cannot
a
actually
galactose,
see
which
it.
looks like
You
this.
must see her
And when you
face
look at
with
these,
the size
you'll
is
notice
actually
that
to
they're
do
very
with
similar
liking.
in structure.
You must be
This
half
is an
alone.
acetamine
Not
group,
alone.
and
You're
this
right
is
there.
a hydroxyl group.
You must have
Even though
right
they
there.
look
All
similar,
right.
though, chemically they are
Maybe
very
must be-
different. They have
No,
different
I don't
properties.
think so.
This group
No, I
is
don't
a
think
hydrogen
so.
bond
But not
acceptor,
sure it's
while the
beautiful.
hydroxyl group is a hydrogen bond
Like
donor. So the
this.
point is
No,
that they do have
there
different
is a
chemical
right
properties,
there.
even though they
Now
do
it's
look
knocking you
rather
back. I'll be
similar.
right
Okay,
right
so
there.
the alleles in the
okay?
ABO
Yes,
system, they're
no.
encoded here at the
All right,
long
you're
arm on
fine.
chromosome
All
9.
right.
And
That's
this,
another
again,
blade
is not
here.
an
Look,
example of
Casper, losing
Mendelian
time.
inheritance. So it might be a little
Oh,
confusing.
no.
There's actually
You're
3
gonna-
alleles
oh,
that we worry about.
You're
But don't worry,
No,
we're going to go
time
through it
to
all.
get out
We're going to use a
here,
lowercase
please.
I
Oh,
to
my
code for the
goodness.
base,
No,
that
I don't get
plain
it.
donut.
No,
Okay?
I don't get
We're
it.
going to use a
right there.
capital I with a
Must be
superscript
alone here.
A
I'm
for
getting
the
here
A
from
antigen.
over.
So that's the plain
Sorry,
donut,
am I?
and then
No,
add
it
the
wasn't me.
N-acetylgalactosamine. And then finally,
Looks
the
like
third
a
allele we have is the
different
B
alien, the
antigen.
nine,
So we're going to
as
take
well.
that base unit, the plain
And
donut,
one
and
here.
we're going
Oh
to
no!
add
What
the
does it mean? You're
lactose.
right there.
Those are the 3 alleles we have. So when you
Right
combine the 3
there,
alleles,
Emily.
we're going to make all 4 blood group phenotypes. I know you want to see how this works. So,
Oh no! What happened? Did
remind
you
you
let
again
someone
what
here?
this looks
No,
like. We're
no.
talking about
No,
A
no, no.
people. They
No,
have
please.
the A
You're
sprinkles.
starting over
There
here.
are 2 ways that someone could inherit
blood
the
type.
A phenotype
There's
or
a blood
the A
type
blood group. You can be homozygous for A, and this means that both parents gave you this allele. So you inherited two copies of the information to make the A sprinkles. But you could also inherit only one copy. So one parent gave you the information to make A sprinkles. The other parent just gave you the plain donut information. Either way, if you're homozygous or heterozygous, you're going to be blood type A. Same thing is true for people who are blood type B. There are two ways to be B. You can be homozygous for B because both parents gave you the information to make B sprinkles. Or you can be heterozygous for B. Only one parent gave you the information. If your blood type is AB, there's only one genotype that is possible. One parent had to give the information to make A antigens, A sprinkles, and the other parent had to give information to make B sprinkles. This, by the way, is a great example of why the ABO inheritance is an example of codominance, why it's non-Mendelian, because A isn't dominant over B or vice versa. So that's a really cool thing to notice. If you are blood type O, there's only one genotype that encodes the plain donut. You had to get two copies of that little I. And that's how you inherit the 4 blood groups. Now, one more thing we need to understand before we talk about transfusions and who's allowed to donate to whom, and that has to do with antibodies. So we've been talking about A and B antigens. These are particles on the cell surface, and you have tons of them, okay? Not just the A or B. The body is full of antigens. They help cells to identify each other, and many antigens are what we call self-antigens. They identify you as you. The problem comes if you are exposed to foreign antigens, strangers. If you're exposed to antigens that are not native to you, your body is designed to make antibodies against them. So you make antibodies against foreign antigens. That's the key. If you've never seen antibodies before, this is what they look like. There's this hypervariable region. This is the part here, as you can see, that binds with the antigen. It's very much like how a key fits a lock. The idea is that if you are exposed to antigens that are foreign to you, you'll make antibodies against them. If antigens and antibodies come together, you get a reaction called agglutination. And this is what normal blood should look like on a microscope slide. You notice it looks very, very nice, and all the cells are evenly spread out. But in agglutination, the particles clump together. And that nice, fluid, liquid blood can become more like a solid and form clots. And this is bad. And this is why understanding blood types is essential when you're talking about transfusions and why this table exists. But now we get to the point where you don't have to memorize this anymore. All you have to understand is that no foreign antigens are allowed. So what we're going to do is we're going to take all 4 blood types, we're going to mix them with the other blood types, and we're going to understand what happens and why some mixes are allowed and some are not. So for a person who has antigen A, the B antigen is foreign, and they have antibodies against the B antigen. So we're going to mix this blood with blood type A, and of course there's no problem, right? That's their blood type. But if that A person gets transfused with a blood sample that contains B antigens, you got a problem, because that B antigen will combine with the anti-B antibodies and the blood clump. So that is not allowed. If you transfuse with AB blood, that's also a problem. The A is okay, but remember, they have B too. So that B is bad and causes the blood to clump. Now, why can you transfuse an A person with O blood? The answer hopefully makes sense to you now. This O is the plain donut. It doesn't have any antigens, so you don't make antibodies against it. So O blood is okay, perfectly fine. What about B blood? Now, the person that has B antigens is sensitive to and makes antibodies against A antigens. So if you have a B patient and you transfuse A blood, not good. You're going to get clumping. A B person with B blood obviously is okay. That's their blood type. AB is not okay because that A is foreign. And O blood is fine. That's just a plain donut. What about AB? The AB person has antigens A and B, and so they don't make antibodies against either. So AB blood can be transfused with all 4 blood types because they got it all. What about O? O individuals have antibodies against the A antigen because those are foreign, and the B antigen because those are foreign too. So you can't give an O person A blood, and you can't give an O person B blood or AB blood. Oh my gosh, that's a double whammy. You can only give O blood to an O person.
I don't know if I know ours here.
So all that you have to remember is that you can't give foreign antigens to someone. And it should make sense now that the type AB is the universal recipient because you can't give them anything that they don't already have. And type O is the universal donor because they are the plain donuts and they don't excite anybody's immune system. Okay, all we got left is the Rh antigen, sometimes called the D antigen. This one's going to be really easy because it's inherited in Mendelian fashion. And by the way, named for the rhesus macaque, in which a lot of early studies were done. The Rh antigen is inherited in Mendelian fashion. You'll be excited to know that. If you're not excited, I have a video on Mendelian genetics, fun with cats and peas. So if I run through this a little bit fast and you're confused with the vocabulary, check that out. I'll put the link in the description bar below. We're going to look at the different options. There are only 3, as is typical for Mendelian genetics. Individuals who are homozygous dominant, capital R, they express the Rh antigen on their red blood cells. Individuals who are heterozygous, that dominant one will mask the recessive one. Those individuals are also Rh positive. The only way to not express the Rh antigen is to be homozygous recessive. These are the different possibilities, and I just wrote them out so you can see that only individuals who are homozygous recessive will not express the Rh antigen on their blood cells. Everybody else will. Now, the medical importance of this is shown here. If you have an Rh negative woman and an Rh positive man, and they conceive a child. Oh, look, she's so cute. She's all like cuddly up against him. He's so positive. Anyway, so I made them both homozygous for their respective Rh types. So she's homozygous recessive, he's homozygous dominant. Their fetus will be heterozygous. So now look at what's happening. You have an Rh negative woman carrying an Rh positive fetus. Now, antibodies flow in one direction from the mother's body across the placenta to the fetus. So it seems a little strange that the Rh antigen being expressed on the fetal red blood cells is not, in a sense, seen by the mother's body. So usually that doesn't occur until the last trimester or usually birth, where there's hemorrhaging and the mixing of blood. And at that point, the mother's body sees the Rh antigen for the first time. And you know what happens when you get a foreign antigen? You make antibodies against it. So from here on out, the mother will make antibodies against the Rh antigen for the rest of her life. She is what we call sensitized. Now, up to this point, there's actually no problem. The problem comes in subsequent pregnancies. If this Rh negative woman conceives another Rh positive child, now the situation is different because she is sensitized against Rh, and the antibodies that she makes will flow across the placenta to the fetus and will cause what is called rhesus disease or hemolytic disease of the newborn. And that can be catastrophic. Now, there's good news. The percent of individuals on the planet who are Rh negative is relatively small. These are data from the U.S., but it's similar around the world. There's even more good news, though. There is a treatment called ROGAM. You can see here when it is administered, and this will actually bind up and block the mother's antibodies and prevent them from binding to the blood cells of the fetus. So that's